Alright everyone, today we're going to look at some toolbox notes. So the title of these toolbox notes should be Triangle Trigonometry. This is going back a couple weeks ago to what we learned. Want to make sure we get some good notes. So if we are given a right triangle that looks like this, right, we should make sure it's a right triangle. So we've got our 90-degree angle here. And if we're looking at this angle, remember this sign, it's like a zero with a line through it, is called a theta. So you're going to hear me call out a theta in this video. If this is our angle, the longest side is called our hypotenuse. The side directly across from that angle is called the opposite side. And the side right next to this angle is called the adjacent side. So, little thing to remember over here, the angle that we're looking at determines which side is the opposite and which is the adjacent. Okay, we could be looking at this angle over here, which means this would be the opposite side, and this would be the adjacent side to this angle. So make sure we remember that. One of our functions is called the sine of theta. Remember, do not call this sin of theta. Myself and Miss Chandler will be very upset. This is equal to the ratio of the opposite side length over the hypotenuse side length. So if we look at a quick example, on this triangle we have a 35-degree angle. We don't know the opposite side length, and we know the hypotenuse is 12. So we could use the sine of 35 is equal to x, our unknown side length, over 12, the length of our hypotenuse. If we multiply both sides by 12, we'll get x equals 12 times the sine of 35. If we use that calculator on Desmos, you should get a number that looks like 6.88 for this side length over here. Okay, our other trigonometric function is the cosine. Okay, so the cosine of theta is the ratio of the adjacent side over the hypotenuse side. So if we look at this triangle, now our angle's in a different spot than the picture on the top. So keep that in mind. This is the adjacent side for this angle. So if we use the cosine of 73, cosine of that angle is equal to x, our unknown adjacent side, over 15, which is our new hypotenuse for this triangle. If we multiply both sides by 15, we get x is equal to 15 times the cosine of 73. And if you put that into Desmos, you should get a number that looks like 4.39 for this length right here of this adjacent side. All right, our third trigonometric function is tangent. Remember, we learned this from slope. So it is equal to rise over run, or the opposite side over the adjacent side, this ratio. This was the first one we learned a while ago. So if we're looking at the angle of 15 degrees, we know the opposite is 8, and we want to find this adjacent side. We can use tangent. The tangent of 15 is going to be equal to 8, the opposite side, over x, our unknown adjacent side. So this is the calculation that's a little bit longer. If we multiply both sides by x, we get x times the tangent of 15 equals 8, and then we can divide by the tangent of 15 and get x equals 8 divided by the tangent of 15. If you do this in Desmos, you should end up with a number that looks like 29.86, which is the length of the adjacent side right here. That's our x. So these are some examples of our trigonometric functions being used in our triangles. And as I mentioned before, remember, when you find your angle, label your sides of your triangle and according to that. All right, there's a little bit more we're going to look at. So we also learned about our inverse trigonometric functions. This is when we know all the side lengths of our triangle, but not the angles. Okay, so if we know the side lengths of a right triangle and not the angles, we'll need to use these inverse functions. So in this triangle, we know the sine of theta, opposite over hypotenuse, is going to be 5 over 13. So if we want to find theta, we'll do the inverse sine of the ratio 5 over 13 will give us our angle. Okay, likewise, if we wanted to use cosine, The cosine of this angle is adjacent over hypotenuse, so 12 over 13. We could use the inverse cosine, that's what this little -1 means, the inverse, of the ratio of 12 over 13 will give us our angle theta. Okay, the last way we could do this is with tangent. So we know the tangent of this angle is opposite over adjacent. Okay, we get 5 over 12. So the inverse tangent of 5 over 12 would be equal to our angle theta. So you guys could test all three of these in Desmos and your angle should come out the same every single time. So go ahead and do that. If you guys have any questions, please feel free to message them to myself or Ms. Chandler. Thanks. Have a good day, guys.